Good morning, good afternoon, everyone. Welcome in this session of Conf42. Today, I'm excited to delve with you into increasingly important aspects of our digital world, container security. As we integrate more with sophisticated technology into our workflow, understanding and securing our containerized environment has never been more crucial than today. So, join me in this session of cracking the code of cloud security. We will focus today on protecting containers, infrastructure, and workloads. Let me share with you a couple of striking statistics based on Aqua Security Report in 2021. About 40% of containers images are pulled from public resources. This fact alone underscores the far reliance and publicly available resources in our container ecosystems. There's a lot of resources out there, but what does it mean for security? While public resources offers a wealth of useful tools and efficiency, they can also bring inherent risk, such as potential vulnerabilities and unvetted content. Compounding these numbers with an issue of having 12% of containers were running as a non-root users, which is a best practice in container security. So we can see that this is a notable point because running containers as a non-root is a recommended best practice in container security. It significantly reduces the risk of privilege escalation attacks, which can lead to unauthorized access and control over containerized application. So as we progress today through our presentation, we'll explore what these statistics mean for your security posture, the challenges that they present, and the strategies that we can implement to safeguard our containerized application. So let's dive in and start to unveil the complexity of container security. I'm today with you. I'm Fouad Mulla. I'm a seasoned cloud security architect and a lead consultant. I worked with many multinational companies to secure their workloads and infrastructure, specifically focusing on the cloud and multi-cloud administration. I'm CISM and CISP and SaaS Plus certified. Feel free to connect with me on LinkedIn. I'm happy to share with you thoughts and perspectives regarding security. Good. Let's start with the agenda. So there we'll have a couple of main topics. First of all, introduction, the background of this presentation and the container security challenges that we might face, that we face inherited from the container security nature, cloud containers vulnerabilities, and container security in the terms of DevSecOps. Enhancing security and going beyond the defaults. Also some kind of tools for automated vulnerability management that we can use, and configuration management and network segmentation, a few points. Also best practices in container security. Let's get started. First, essentially, you don't really need containers to ensure security of your application. There's plenty of technologies and tools that you can use. However, by using containers wisely, and many lines under wisely, you can really enhance your application security. Containers are not really prerequisites to say for securing application, but if you use it in a good manner, you can offer a runtime separation of your app on host. You can only deploy what you need, so there's a little bit, or there's a smaller attack surface. It's easier to set up, which means it's easier to patch. There's a predefined setup, so which can increase also consistency, which all the security personnel loves. As overall improved security through their isolated nature, which can help in containing breaches, for example, minimizing the impacts. However, this benefit is only realized if the containers are managed and configured securely, adhering to best practices in container security. Also, to say you don't really need advanced security tools to start with containers. There's a lot of open sources, there's a lot of technology in there which you can use, but you really need to consider security to effectively use containers. Using containers without thinking about security is a recipe for a disaster. So always good to understand and implement security best practices like, let's say, image scanning, container isolation, least privileges, access, zero trust principles are really essential to maintain the security and the integrity of the containerized environment. So challenges in container security. First of all, there's a couple of points here. I just state a couple of them. There's a lot actually. First, the daemon attack surface. So this is the this you can it's inherited from the essence of the technology we are using. There's a potential vulnerability in the container's own systems. It's relatively a new technology. It's similar to the virtualization on the VMs and virtual machines, but it's far behind in regards of vulnerabilities in this new technology. Secrets management, and here when I say secrets, I'm not only referring to credentials, passwords, etc., but more also referring to the container's images itself. This has to be considered also as a sensitive, and we'll see this afterwards in a couple of slides. There's also untrusted content risk. There's a danger of using, for example, compromised and vulnerable images. There's challenges in the growing environment of containers, and also the ephemeral runtimes, which can have a kind of a special characteristics in incident management and such. Also in the lightweight isolation risks, so this can has also a lot of challenges to be considered. For example, when speaking of the daemon, only trusted users should have access to the API. We have to set also operation system permissions. We shouldn't expose this API unless it's really needed, and using TLS and patching the system whenever possible. There's a couple of challenges actually in tracking and managing this on a large scale dynamic environment, special limitation from WAFs and IDS and IPS in this regards. Containers offer relatively weaker, as I mentioned, separation than VM, so this has to be considered in many scenarios of breakout. There's also security operations teams need to have some kind of a good pictures of what threats are going on this dynamic environment. So collaboration is really important. It has to come to the organizational culture to be coherent with this technology and to be empowering the team. So without help from SecOps, the build process could be really stalled due to unlocate undetected vulnerabilities. Since containers in the nature are ephemeral, meaning that they quickly spin out and really fast being destroyed, so it's really hard to detect and monitor changes on them, especially in complex systems. Also, it's sharing resources like CPUs and then a lot of resources from the host. So it's just really challenging to have a track of records of what's going on the physical system. In my opinion, to help really the SecOps to help you look into the security tools that provide comprehensive visibility without interfering with your job. So the right tool should give you the sufficient metrics, numbers, logs that you need to properly monitor and measure the health. Don't forget also to observe the network, as this is kind of, let's say, a no-brainer in security and cloud security. Cloud containers vulnerabilities. Here, basically, as kind of a summary, this list can go on and forth. There's a lot of points that we could mention, but here are a couple of points. So the images has to be dealt as a sensitive information. These images can, if it's not tracked and scanned, it might contain vulnerability or any outdated components. Also, if these base images are not regularly updated or scanned, this can pose a potential security risk. There's also the insecure containers runtime configuration. I will touch about this a little bit further, but in essence, default configuration is not secured. Containers and misconfiguration is kind of tight. There is no default there's no secure by default setup in containers, so it has to be looked at from early stages. Usually, we found vulnerabilities in the network segmentation. This is sometimes forgotten from the setup. Containers sharing resources on the network. So if one compromise, this can be potential privilege escalation or a container escape risk. Without proper segmentation, the attacker can potentially gain access to other containers on the host system. Also, the escape vulnerabilities, which I just mentioned, orchestrator vulnerabilities, that the orchestrators, like, for example, Kubernetes, can have vulnerabilities that, if exploited, can really lead to a cluster-wide impact. So it can have a really hard and tough implications on your organization. This includes issues with API configuration and setup and authentication mechanism. Also, sometimes dependencies can be kind of challenging or a challenging vulnerability and container registry. There is a solution out there, so keep track of what container registry you wish to use. But it's crucial to use trusted registry and scan the images for vulnerabilities. Of course, as well as logging and monitoring the gaps. Finally, using immutable and ephemeral nature. This can pose really vulnerability of incident investigation, and containers might be terminated and replaced before the investigation can be taken place. So that has to be in the incidents plan, being somehow tackled, as well as with the logging and keeping all the records that might be needed for such a case. So let me share with you kind of a little of insights of a cloud setup regarding containers. However, well, really, you can use any technology here. I'm referring to the AWS cloud, but you can use Azure, you can use Google. All is good. Good to mention a couple of points here. So, for example, you can use the code commit service from AWS, but I really highlight that the use of Code Guru for tracking if there's any credentials or any sensitive information that is embedded in the code, so you can have early stages check. You can also use hooks on the dev team with the dev team, but this is also kind of a second or multi-layer defense methodology. I would like to highlight, well, also probably possible to use the AWS Secret Manager. Here you can see that we are using it for managing the secrets on the production and on the environment. Good to mention as well the use of, for example, the SAST scanning. Well, there is a lot of technology that here I kept it open, but for example, Dockerfile lint. It's a rule-based linter for Docker files from Red Hat. You can check the syntax and run semantics and check for best practices. And it's really customized with the YAML language, so you can just right away use it. Also, another smart SaaS tool can be used is Hadulint, which also you can get access to it. It's available, and it really gives you a really good insights regarding your container or regarding your image. Also, you can have, well, obviously you might have DAST testing. This is on the interface level, so your options is quite wide and open. And finally, use the identity and access management on your cloud setup. That's kind of no-brainer. And keeping your cloud watch here, logging and checking all the logs on production, and also as needed on the other environments to ensure integrity and track of records. This is in a nutshell. So. Typically, when we are using cloud, and especially with DevSecOps, we are in a race for deployment and for speed of pushing features. So it's a good practice to use infrastructure as a code. It can really streamline the process and keep the consistency in the environment. So how to enhance the security? let's go a little bit beyond the defaults, and this is let's say a good takeaway from this presentation. So always the Dockers, for example, built-in sandboxing and runtime protection are a very good start. However, it's not a never complete solution, so always have to work a little bit further. Always the balance between developer flexibility and the security on the other hand. So find the right equilibrium between to ease of the developer and make a robust security protocols. Finally, managing images with care. It's very good to highlight. Treat containers images as sensitive data. Implement strict access control, regularly review and scan the content of images. So also how to enhance the security also beyond the default. Here I made a kind of like a further points that were good to mention. Always use trusted base images. So start with official, minimal, as much as possible base images. Avoid unnecessary packages, unnecessary tools to reduce the attack surface. Regularly scan for vulnerabilities. So you make this part of the pipeline of deployment and development. Implement least privileges access. This is kind of essential. And use immutable containers. So containers should be always immutable and disposable. Only deployed. And they should not be modified. If any change needed, we replace the whole containers with a new one. And as much as possible, let's use read-only file system. So this will reduce a lot of potential persistence by malicious actors. Manage the secrets securely. So use a good tool and good system to handle sensitive data and never hard code secrets in containers images. Use secure network best practices, network segmentation, and also good to mention resource limitation. So enforce some limits on your resources to prevent any DDoS attacks and exhaustion on the system resources. Using policies and security context. For example, when utilizing orchestrator features like Kubernetes security context, bot security policies or equivalent in other orchestrator to enforce these security policies. Use isolation as much as possible, especially when speaking with sensitive data. For example, a strong mechanism can be used. GVSR or Kata containers can be really good tools, or also you can use the native hypervisor-based containers to isolate it on the host system. Configuration management we'll touch on in a couple of slides. And of course, keep the security embedded in your pipeline. So integrate security with checks, continuous development and deployment, and make education awareness among the whole organization. A couple of tools here just to highlight for automated vulnerability management. Is really useful to use Anchor. It's an open source tool for image inspection and vulnerability scanning. Again, accessed via GitHub. It provides a really centralized service for inspection and analysis. So the Anchor engine can be integrated with the CI/CD the pipeline to ensure that only secure and compliant containers are deployed to production. Another also good tool is Clair, developed by CoreOS. Here is also it's possible to get it from GitHub. Designed to scan containers for known vulnerabilities. What is good and nice that give you the ranking of the CVE, so you can get the numbers and you can identify security issues in early stages to be addressed. There's a lot of tools out there. Also good to mention AWS image scanners in private registry, so it can be also used for making sure that your images are scanned and in a good health before deployment. Few points regarding configuration management and network segmentation. I would highly recommend implement microsegmentation. So always fine-grained network policies as much as possible. Control communication between your microservices and containers. Leverage the namespace. So utilizing this in Kubernetes to segment the resources. It's kind of a good boundary for the network policies. Also use network policies to for example, especially in Kubernetes, to define which network connection is allowed or blocked. By default, make block or deny for everything. Then start to add what you need based on your setup. isolate sensitive workload, especially when dealing with compliance if you have like a compliance issue, that it's really helpful if you start from sensitive load workload isolated, and then opening the, let's say, the what you need from this workload to be processed or to be used. So that can help you in your journey for compliance. Also, always, this can reduce the risk of exposure to other network traffic. Encrypt the containers traffic, use TLS to communicate, make audits, regular and periodic audits, so I can give you some insights regarding also your policies. Good to mention also using the service meshes. It's really good technology. It can help you to go deeper on the level of containers. So, for example, Istio or link card, you can use it for advanced traffic control, monitoring between your services. Monitor these activities and integrate with your security tool. So if you have a WAF or technology you are using, IDS or IPS, you can use it for make another layer of logs and checks on your network. So let's recap. A few points here I'd like to highlight. First of all, containers can really improve your security if used wisely. So as we've seen, it has a really good potential. It has to be took into consideration all the setup beforehand. Docker is not secure by default, and in a sense, containers is not secured as a system, is not secured by default. Never depend on the vanilla configuration. Always do your own setup and your own care of this technology. Always treat images as a sensitive data. As we could see, there is a lot of vulnerability and potential gaps that could be happen if you are not tracking your images. Finally, also follow network and configuration best practices. I shared with you a couple of them. There's a lot more, so you can always keep track of these kind of best practices. Finally, use automated tools as much as possible to integrate your security into your DevOps pipeline. Finally, I wish you that no image of yours has any image problem. So thank you for joining me in this session, and feel free to connect with me via LinkedIn, and I'm happy to be with you here. If you have any question, reach out to me, and have a great day. Thank you for joining me in this session, and have a good day.